In this proof, number two, we have two pieces of given information again, and they both refer to a midpoint. So let's remember that a midpoint is a point halfway between two other points. So it's the halfway marker, it's directly in the middle of a segment. So it's going to divide a bigger segment into two smaller equal segments. So we'll read that carefully. We can also notice that this diagram has two separate triangles that meet at a point, which is going to be a relevant piece of information here for us to look for soon. So let's go ahead and start with our given information. The first saying D is the midpoint of segment AF. And so what we should do is we should find point D and realize that AF goes from here, top right to bottom left. And what this statement is saying is that D is in the middle of A and F. So the distance from A to D is the same distance as D to F. Okay, so we should be able to look at that given information and realize it's telling us that we have two equal segments here and here. And the reason, again, is not given because in our given information, it doesn't actually say that a segment AD is congruent to segment DF. It said that we have a midpoint. And so the way that we were able to mark this diagram is by knowing that we had a midpoint. And so the reason for that is very simple. It's just definition of midpoint. So we'll mark it there. We'll mark it in our final diagram as well. And then we use the next piece of our given information that says D is the midpoint of EC. And so kind of similar to the first piece, we're talking about point D again, except this time point D is in the middle of segment EC. So it's directly in between E and C, meaning the distance from E to D is the same distance as D to C. And just like before, this wasn't given to us. Rather, we knew we could mark this because we were told about having a midpoint. And so we won't put given here. We'll put definition of midpoint because it's that word midpoint that told us that we could mark the diagram in this way. We'll mark it here. We will mark those same segments here in the final diagram. And so recall we need a third piece of information. All of our triangle congruence theorems have three pieces of information as congruent, whether it's side, 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 angle, angle, side, or angle, side, angle. And so the question is, do we know if the last pair of sides are congruent? Can we assume that just by looking? And that's not something we've ever been able to do. So there must be a pair of angles that are congruent to us. And if you recall, when two lines intersect, they create what are called vertical angles. And those vertical angles are guarantees to us. Those vertical angles are always congruent. And those vertical angles are across from each other in this X formation. And so what we see is the two angles at D, here and here, are vertical angles. And that is a guarantee to us always. We never have to be told this information. We need to know that the definition of vertical angles always applies when we have them. So we have very few guarantees. This is one of them regarding angles. Earlier in proof one, we saw the reflexive property for a shared side. Really, we don't have many more guarantees than that without more given information. But we mark that here as well. And you see in these two triangles, in each of them, we have two pairs of sides marked as congruent and the angle where those sides are meeting. And that is our theorem of side angle side, which is enough to show the two triangles are congruent to each other.